Hey guys, it's time for chips in the mail again. I was excited to see this one arrive. This just came in from Adafruit, and you know, I only ordered this about 2 days ago. I pre-opened the package, but let's have a look again and see what's inside. Did I get it all? Yeah. Well, I ordered myself a pair of those fancy clippers. I needed those, so it's got some diagonal cutters. We'll set those aside for now. This is the part that I was excited about. This is a new product that they just introduced. Look at this. This is a switch pad. Soft, kind of silicone buttons, 16 of them, and they have a little conductive ring on them. And I don't know why, but you have to order these two things separately. There's the buttons that go there, and then there's a board. Come out of here. That works with it. So you see the buttons fit on top of this board, and those rings then look like they're going to make contact with these circular patterns on this side of the board. Then the other side of the board has a chip that handles all that. There's connections here on all four sides. They're identical connections all around. That allows you to hook up to 8 of these boards together in any pattern that you want. And you just solder these connections together from board to board. But it uses an I2C communications protocol, and we'll talk to the Arduino using these pads here. So we have the SDA and the SLC, which is the only two lines you need for I2C. We've got ground and 5 volts, and then they've added an extra one here, INT, which I've looked at this stuff online. That's an interrupt. So we can send an interrupt signal to Arduino when we want to. So that'll be cool. And all that puts together. So I'll be excited about giving this a try. They've just come out. I think I've got in on the first batch of orders. Well, I've had a lot of time to experiment and play around with this project since you saw me open it up. And I've written a sketch that turns this trellis into a 4x4 CW keyer. I've actually used it on the radio and had several QSOs, or conversations, with hams around the country using Morse code. But instead of sending Morse code with the traditional key, I'm sending Morse code with these buttons. We'll take a look at that in more detail later. Let me pull this off and I'll show you what I've done. I've soldered a cable on to the back here so that we can connect it over to an Arduino. I've also soldered 16 LEDs onto the top of the board. It calls for 3mm LEDs. I only had the two colors, blue and red. I would have liked to have one more color. These two keys right here have a special purpose, and it would have been nice to maybe make them a green color or something different. Let's put this pad back on. Now, there is one problem I have with this video, and that is these lights, when they light up here, are so bright that they wash out the camera. So I've used a command that comes with the library that will display these lights as dim as possible, but they'll still look pretty bright in the camera. You'll also see some flicker that the human eye doesn't see, but the camera seems to do a good job of picking it up. Let's plug this in and I'll show you what happens. Let's give it some power with a USB. And there, it's up and running. Let's take just a moment to talk about what's going on with the Arduino here. Our cable runs over here. We've got 4 wires coming from the trellis, and 2 of them are simply providing 5 volts and ground, and the other two are the I squared C connections. We use I squared C, sometimes people call it I2C, to communicate with the trellis. There's a great library that gives us a whole set of commands that allows us to tell whether buttons have been pushed or not, and also to turn individual LEDs on and off. I have 2 other wires hooked up here to the Arduino. These run over to my electronic keyer, which is then connected to my amateur radio. So the Arduino here will read the trellis pad. It will determine what Morse code characters need to be sent, and then that will be output through these connections here.
I'll be running 2 cameras here simultaneously. One down here will show you what's going on with the trellis, and the other over here will show us the LCD display screen that's part of another project that you may have seen on some of my videos earlier, where I've created an Arduino that can copy Morse code right off the air live from my receiver. But for now, we'll be just taking the tones generated by the trellis and displaying the letters over here on this display so that you can see what's going on. Let's take a moment to look at another project that I've been working on. This little board right here has 8 switches on it. My plan was to build an electronic keyer, a means for me to send Morse code over amateur radio that's a little different from some of the traditional methods. I've attached 8 leaf switches to this board here. These switches up here send various combinations of DITs. These switches over here send combinations of DAWs. In fact, these 8 switches that you see over here on this original project correspond with the top 2 rows, the top 8 switches over here on the trellis. Well, let's talk about how the trellis came into this picture. One evening, after I'd been working on this leaf switch project for a while, I took a break and watched some videos on YouTube. That's where I saw the introduction video to this new product that Adafruit was just going to release. Let's take a look at just a small part of that same video.
Next, this is the big announcement. This is the big product. This is it. Introducing Trellis. This is Trellis's logo. Trellis is a new open source button platform. Here is Trellis in action. And I'm going to show just some photos of the board itself as they do to get set up.
So, let me explain just in case the overhead is being naughty. So there's these rubber buttons that are like rubbery elastomer buttons, kind of like you see on like a washing machine or like a calculator or whatever. And they come in a grid of 4x4, and they're 10 millimeters by 10 millimeters by 10 millimeters. And then there's 5 millimeters in between. Each button is made out of this kind of translucent silicone. And there's a little cavity inside of it, and so you can fit an LED inside. So if you have a circuit board with LEDs that are spaced the right way, and then you have these conductive pads that can be bridged with the elastomer, you can make a 4x4 grid that's illuminated. And so it's actually a 2-part thing. There's the rubber button, and then there's a circuit board. The circuit board actually handles the button pressing and the LED lighting. The elastomer doesn't have any intelligence in it. It's just like rubber buttons. Like it doesn't do anything. It just has these little contacts that can close a switch, and it has the button effect because it's got these the way it's machined. When you press the button, it has a nice little button press effect. I don't know there's some name for it, but it has a little like spring, like a live hinge spring in it. And so the circuit board is what actually does all the hard work, lighting all the LEDs in order and reading the switches. And then if you combine that with an Arduino, which does the actual brain power, you can, for example, light up the LEDs when the buttons are pressed, or alternate the LEDs when the buttons are pressed, and good stuff like that.
Okay, let's try to go there.
So let me try to go to the overhead.
Okay.
And now I'm going to turn this, so this makes it show up a little bit better. So I can press the buttons, and
this is a cool demo.
They will turn on. So this is the demo that I wrote. This is a demo called latching demo. So this turns on the LEDs on and off. And this is just one square. So this one square is 4 by 4, and then the button's on top. But if you want to go crazy, because who doesn't want to go crazy, you can update it to do up to 8 of these panels tiled together. Oh.
Yeah.
Okay. Yeah.
All right.
Okay. So this is, so you can see here's that circuit board. You see the LEDs, and then this one has the elastomer on top. And then you can press all these buttons, and each one will light up, and it's like glorious and blinky. So this is 2 by 2 for 4 total. But of course, you can have 8 total, and I just didn't want to solder more up because I was busy doing the tutorial. And it's kind of flickery because there's the refresh, but that doesn't actually show up in real life because it's refreshing faster than people can see.
Yeah. Okay. That is new products. Thank you, Lady Ada.
Yay, I got through them.
So you can see why I like this product. I also like ordering from Adafruit. Adafruit.com. I go in, order it online, and 2 days later, it's at my door. And one of the best things is all these products are made in the United States, right there in New York City. Let's take a look at how the keys are organized here. The blue keys are all used to send all of the letters and digits in the alphabet. There's 2 extra pair keys at the bottom there that actually send punctuation marks. The red keys are kind of command keys. We can do various things with them. We can record text. We can send pre-programmed strings of message, all done with the red keys. Let's see how this works. Remember, we have the dits up here and the DAWs down here. So let's send 1 DAW. The letter T. 2. An M. And 3. And then finally the letter N. Up here with the dits we've got E, I, S, and finally A. That's only 8 letters, albeit it's the most common 8 letters that we use in the English language. There is a way for us to send every letter, in fact, every number as well, using these top 2 rows. I came up with the idea from thinking about our mouse. With our mouse, we have a button that we can click. We can also double-click it. And it does a different function, depending on whether we click it once or twice. Well, we can do the same thing here. I realized that with 16 keys here, I could double-click any one of them. And then it occurred to me that my double-click doesn't have to be the same key twice. It could be 2 different keys. So let's look again at this organization and see how we get other letters. Let's consider the letter K. In Morse code, the letter K is DAW to DAW. We don't have any key that does that. But we do have a key that sends just 1 DAW right here. We also have a key over here that sends a DIDAW. So if I push them together, we can get a K. Just like that. How about another letter, like the letter L? Didaw, did it. Well, here's a didaw. Here's a did it. The letter L. How about the letter J? That would be a dit right here and a daw, daw, daw right there. One more, the letter R. Dit and daw dit. Now, that letter R could be sent another way. It could be sent as a didaw and then a dit. So we can create the same letter by pressing different keys. What's really cool is that every single letter and every digit can be sent by pressing either 1 or 2 of the keys in this top 2 rows. Now, I was a little bit surprised to find out that learning which ones to push came very quickly. So I think if a person already knows Morse code knows how the letters go together, it starts to become obvious. In about 15 minutes, 20 minutes, you can start sending letters left and right. They just automatically come out. I've used this on the radio talking to people, and it works quite well. Let's talk a minute about these two blue keys in the third row. These also send Morse code. I set them up so that I could use them to send punctuation marks. So if I need to send a period, I just push this one. If I want to send a comma, this one. Now, if I want a question mark, I double-click this first one. And in amateur radio, we use a slant bar quite often in some of our call signs. So I double-click this one to get a slant bar. Now let's talk about these two red buttons in the third row. They each do two different things. First thing they can do is they can record text for me. I have two memory banks where I can store text. I can store a person's name here. I can store the person's call sign there. Why would you want to do that? Well, in amateur radio, we have to send each other's call signs many times, so it's convenient that to record it the first time I send it, and then I can just simply push one of these buttons when it needs to be sent again. I can do the same thing with a person's name. Let's say I'm having a conversation with my friend Peter and I want to record his name. This is the button I use to do that. Watch what happens to my display when I hit the record button. I get a flicker and it changes the pattern here that's lit up. That lets me know that I'm in record mode. Anything I send now will be stored in the Arduino's memory. So I'll send Peter's name. And I'll stop recording by pushing that same button. Now let's talk about this bottom row of buttons here. These are my memory banks. I have 4 messages stored under each one of these buttons. How do we get 4 for a total of 16? Well, you've heard me talk about the single click and the double click. That covers half of them. I'll explain the other 2 in a minute. But let's say that I'm having a QSO, that's what amateur radio operators call conversation, with someone in Morse code, and I want to tell them what my name is. I could just push this button here. When I push this button, watch the top 2 rows. You'll see this one blinking with each character, and then they will start to fill in across here. I've turned the top 2 rows into a progress bar, and you can watch as I approach the end of the string of text that I'm sending. When I get to the last character, this last LED over here will light up. Watch, here's how it goes. There. I've sent a pre-recorded string of text just by pushing one of these keys. As we start to finish up here, I'd like to show you something special about these 2 red buttons in the third row. We talked about how we could use them for recording. If I double-click them, they have another purpose. I can double-click them and use them to set the speed that the code sends. Now, this one right here controls the words per minute. That's the speed of the dits and dahs. This one over here controls what we amateurs call the Farnsworth speed. It has to do with the gap, the space between the 2 letters. We won't go into a lot of detail about that. We'll just focus on this one right here. If I double-click this one, something interesting happens. This display up here is actually telling me the speed that the code has been, the default speed where we've been sending. This top row right here represents units of 10, and the second row represents units of 2. So here we have 10, 20, 30, 40, and down here we have 2, 4, 6, 8. So right now, these two LEDs tell me that the code is set for 12 words a minute. Let's change that. Let's go to 20 words a minute. I'll turn this one off. So now we only have 10, 20. Now I'll push this button again here to save it. Remember when I pushed this button here before, it sent my name? This time I'll double click it and it'll send something different. But notice it'll also send it faster. Watch how it sends that name that I recorded earlier. Well, let's speed this up even more. It'll help us finish this video a little more quickly. I'll double click here to change the speed. Remember, it's set for 20 words a minute. Let's take it up to 32 words a minute. See how that looks. Okay, we've demonstrated single clicking a key down here in our memory banks and double clicking a key down here in our memory banks. But there's two other things I can do. I can press one of these keys up here first and then follow it with a key down here to get a third and a fourth string of text. So let me demonstrate that. I'm going to just use this memory bank down here, but I'm going to send two strings of text this time. The first one, I will push this guy right here first and then that one, and it's going to send my location. We call that the QTH. It'll tell me, it'll tell people where I live. And then follow that up with the fourth memory bank from this one by pushing this one first and then that one, and it'll tell you just a little bit more about where I live. So let's give this a try. And now the last one. There you have it. This has been another fun Arduino project, and I've been able to get it on the air and use it with amateur radio. It's worked quite well. But, you know, it has one limitation, and that is that despite the nice feel to all of this here and the great tactile sense, I can only push these buttons so fast. So that limits how fast I can send the code. So if I wanted to send Morse code more than 15, 20 words a minute, it's probably not the best choice. There's some more traditional ways that will work better. But a lot of the times, that's not a problem because there's a lot of new hams on the air now who want to send Morse code slow. And it sure is fun talking to them. So I hope you've enjoyed this video, and maybe you will find a project that you can use an Adafruit Trellis for. See you later. 73. And hey, don't forget to subscribe, like, and share.